Hello. Already we learned series. Now we are going to move to the third type of test that we're going to learn under series. If I recall your memory, we have already learned geometric series, and then we already learned telescoping series. Now, as the third part, we are going to discuss a test which is called n-term test. Okay. Before moving to the n-term test, um, you can use any of these three methods to check whether the given series is convergent or divergent. All right, so you know how to check the given series to convergent to divergent. So this is the third entity that we're going to learn, that is the n-term test. All right, let me write down the n-term test first. Theorem. This is the n-term test theorem. If limit n goes to infinity, an does not equal to 0, then sigma n goes from 1 to infinity, an diverges. Okay, that means you just take the n term and then you send n to infinity. If that does not equal to 0, then it diverges. Okay, if this happens, you say it is the series diverges. Okay, so there's a very important thing. This theorem can be used to show convergence. Again, I'm telling you, this theorem can be used to show convergence. This is a test only for divergence. Okay, let me write down that as a point. This theorem can be used to prove convergence. All right. So let's move to the first example. This is example number 5 in this section. The section that we are in is series. We discuss two parts, two topics of that section. This is the third topic. The third topic is n-term test. So now we have the fifth example. It is sigma n goes from 1 to infinity, n plus 1 over n. You have to check whether it converges or diverges. You have to check whether this converges or diverges. First of all, you have to find the n term. Here that is the n term. So you write an is n plus 1 over n. Okay, now you have to send n to infinity. Limit. You have to send n to infinity of an. This equals limit n goes to infinity, n plus 1 over n equals limit n goes to infinity 1 plus 1 over n. When n goes to infinity, this will become just 1. Okay, then by the n-term test, sigma n goes from 1 to infinity, the given series diverges. Okay, so an is just 1. It does not equal to 0. Let me write it here. an does not equal to 0. Oh, I'm sorry. Let me rewrite this. What I'm saying is limit n goes to infinity, an does not equal to 0. That is the n term test. Alright, so the series diverges. Let's move to the next example. Example 6. You have this series sigma n goes from 1 to infinity, 3n minus 1 over 6n minus 1. You have to find whether this converges or diverges. Alright, first of all, find the n term. This is the n term, which is 3n minus 1, 6n minus 1. Alright, now just use our approach. You have to send n to infinity. So let me write this. Limit n goes to infinity, you have to find an. Limit n goes to infinity, an. Alright, this equals limit n goes to infinity, 3n minus 1, 6 to the power n minus 1. Alright, now this is what you have. Now you have to simplify this. For that, what I would do, I will divide this by 6 to the power n minus 1 and that by 6 to the power n minus 1. Then this is 3 to the power n minus 1 over 6 n minus 1. Alright, now you can simplify this part. So you write limit n goes to infinity, and then you write this part as, you can write it as 3 over 6 to the power n minus 1. You have learned this in your Calc 1 class. This is, you learn this one in indices. You learn indices and exponents in Calc 1. And then here you write minus limit n goes to infinity, 1 over 6 to the power n minus 1. Alright. So now what you do, you just simplify this. This is half, and then you write this as limit n goes to infinity, half to the power n minus 1, limit n goes to infinity, 1 over 6 to the power n minus 1. Alright. Now you apply the limit. Here you will get, once you apply the limit, you will get, what you get here is 1 over 2 to the power n minus 1. Now n is infinity. You get 1 over infinity minus 1 over infinity here. 1 over infinity is 0, then 0 minus 0 is 0. Alright, what you get here is 0. Now go back to the definition. The definition says if limit of n goes to infinity, an should not equal to 0. Okay, so this is the limit of an when n goes to infinity should not equal to 0. So what happened here is it equal to 0. It is equal to 0. So that means you can't apply this theorem. Okay, you can't apply this theorem. N-term test can be applied. So you have to find some other way of solving this problem. Okay, let me get these extra lines. Okay. Now you have to find some other way of solving this. First of all, let me put a small note here. Since limit n goes to infinity, a n equals 0, nth term test fails. All right. Then how do you solve the problem? We use the geometric series approach. Then use the geometric series approach. All right, so this is the given problem to you. Let me write that. The given problem is sigma n goes from 1 to infinity, 3 to the power n minus 1, n minus 1 over 6 to the power n minus 1. Okay, so this is the given geometric series. This is the given series, so you have to find geometric series out of this. For that, you have to make a small modification. So what I'm going to do is I'm going to convert this series into two series like we did before. See, I made two series out of that by using this approach. It's right here. I made two parts from the given single part. I made two parts out of this single part. So that's what I'm going to do here. I'm going to make two series out of the given series. For that, I will write like this. This equals sigma n goes from 1 to infinity. Then I will divide 3 to the power n minus 1 by 6 to the power n minus 1 minus 1 over 6 to the power n minus 1. This equals sigma n goes from 1 to infinity. And then here I write 3 over 6 to the power n minus 1. Sigma n goes from 1 to infinity, 1 over 6 to the power n minus 1. Alright, now you can simplify this as sigma n goes from 1 to infinity. This is half to the power n minus 1. This is negative sigma n goes from 1 to infinity. This is 1 over 6 to the power n minus 1. Okay, let's consider this as series A, that as series B. So you have two series now. You have to evaluate each series separately. Let's consider A first. Series A. Series A is this sigma n goes from 1 to infinity, half to the power n minus 1. Let me write few terms of this series. If you write few terms of this series, you first try n equals 1, then this power becomes 0. Then what you get is 1. And then let's say n equals 2, then this power becomes 1, then it is half, then 1/4, 1/8. So these are the first four terms. All right. Now, first of all, you have to find the common ratio and the first term. So those are the key things in a geometric series. The first term is denoted by a, which is 1, and the common ratio is just divide half by 1, which is half. That is the common ratio you have. Okay, the ratio is same throughout this series. All right, let me write this is the first term. This is the common ratio. All right, now you know A and R. Then you can find the sum of the series. Then you have to find the sum of the series. We know the sum of the series. There's a formula for that. Sum of the series is actually A over 1 minus R. We have learned this in the previous title. In the same section, previous title, we use this formula. Then just plug the values into this formula. So this will become A is 1, 1 minus R is half. So this will become 2. Okay, so that is the sum of this series A. Now move to series B. Okay, first write down the series, which is sigma n goes from 1 to infinity. 1 over 6 n minus 1. Just write few terms. When n equals 1, you will get 1 here, because when n equals 1, this will be 0. 1 6 to the power 0 is 1. And then when n equals 2, this will become, this power becomes 1. Then it is 1 over 6. When n equals 3, this becomes 2. Then that is 1 over 36, and so on. Right, so these are the first few terms. First 3 terms. Now you have to compute the first term, which is just 1, and the common ratio, which is the ratio between 2 consecutive terms. It is actually 1 over 6. Okay, so again we know the sum of this series. The sum of this geometric series is A over 1 minus R. A is 1, it is 1 minus 1 over 6, which is 1 over, let me write it, yeah. Let me take this one here. This is actually 1 over 5 over 6, which is 6 over 5. So that is the sum. Alright, so just take this as equation. Let's take this as equation 1. Take this as equation 2. And take this as equation 3. Now what I'm going to do, I'm going to substitute equation 2 and 3 into equation number 1. 2, 3 into equation number 1. That will give you A and B. Alright. Substitute. We substitute 2 and 3 into equation number 1. So what we get here is this big series given to you. N goes from 1 to infinity. 3 n minus 1 minus 1. divided by 6 to the power n minus 1. So that is actually this a minus b. Our a is half. So our a is 2. B is 6 over 5. Alright, so let me delete this. So the solution here is 10 minus 6 over 5, which is 4 over 5. Alright, now you have to check this series converges or diverges. Now the entire series has a this is the entire series. The sum of the series is actually a real number. It is not infinity. It has a finite number, finite value for the entire series. So there was a definition which says if the sum of the series is finite, then that series converges. So the conclusion is this series converges. Since the sum is finite, the given series n goes from 1 to infinity, 3 n minus 1, 6 to the power n minus 1 is convergent. Okay, this is convergent. Alright, so we discussed two problems under this title. This title is n-term test. The first example was right here, which was example number 5 in this section. So we showed that this series diverges because we got the limit as 1, which is not 0, so it diverges according to this theorem. And then we move to the second example, which is complicated, which is an advanced example. In this example, we just tried the n-term test. That didn't work. Because of that reason, we have to use the geometric series approach to find the solutions. All right, so that's all. Thank you very much.